Hello everyone, today is the second lesson for the bootcamp and we will try to go into different things this time, into loops, arrays, in general, how can we control the flow of our application, and some operations with string, how to parse a more complex text. So in this lesson, the whole focus will be on the requirements from the previous problem, from the recipe problem, to convert the units of cooking into standard units that everyone can understand, so that we can avoid, relative measurements. Instead of cups, we'll use milliliters and similar stuff. So let's get started. So I would like to start with a problem itself, introducing you a recipe for something we know very well, which is pancakes. So I'll just take the ingredients list for pancakes and paste it here. I will slightly, clean it up. Okay. So this is our pancakes. So imagine a user comes and inputs a recipe, or at least the ingredients list. I'll do so. Hello guys. So we read user input just like normally. Yes, I will try to fix it later after this lesson. Now we'll have to, deal with it. I pressed Alt-Shift this time. All right. So imagine this is the user. They come. They come, and unfortunately that did not work. Okay. Let's move all to one line. So let's say this is our recipe. 2.5. Okay. These are our ingredients, and user is required to please enter the ingredients. And we will enter the ingredients. So I just copy this. And that's good. And that's the user input. So let's take a moment to analyze what's written here. So we have 1.5 cups of flour. So cups will need to be converted to liters or milliliters. Teaspoons, again, will need to be converted to milliliters. Teaspoon to milliliter, teaspoon to milliliter. Cups to liters. And 1 egg, 3 tablespoons, again to milliliters, and that's all. So as we said in our initial assignment, we are going to convert all those into standardized units. So we have cups, teaspoons, tablespoons, and that's all. So cups, teaspoons, and tablespoons. I will extract that information as a comment for myself. So let me just move stuff down so that's not in the way. Key metrics, cup. I will copy this. Cup. Teaspoon and tablespoon. Just marking stuff, the key information, so that we visualize the problem. Basically, whenever I discover these metrics, I will need to replace them with their standard unit equivalents so that it is easier for someone who has zero experience with cooking to understand, not to guess how big is what, but to be very accurate with the exact metrics measurements in standard system of units. So these are the metrics of cooking units exactly as they are. And our goal now is to convert this recipe into something that, into basically those units that we just wrote here. So in order to be able to do something like that, we need to learn a few new things. First, we need to learn how to process, like the approach itself for processing such line of text. What's the approach? So for now, I will take this as input because there's no point to keep on reading this constantly if we are going to base everything on this specific recipe for now. So I'll just say that this is my input. This is what I will be working with. Let's make it fit in one page. So in order to process this, I should first try to somehow split this into words for units, into words for amounts, into words for units, and into words that are unrelated to the unit and the metric itself, basically other words. So I need to split this text into parts, into words, before I can process it. So in C#, you can split text into parts using a split method. I will do that. If I write ingredients split, and I say that I split by an empty string, it will return words. So, and now again, we are looking at another new thing. This is text, a single variable. Then we split stuff, this single text. We get words out of this. So we are no longer working with a single value. We're working with multiple values. And those multiple values actually mean that they're words. So regardless of being multiple values, I can still store them in one thing. So that one thing is called an array. This is an array. This is an array of words. And we produced such an array after we split this text by empty spaces. So for now, that will do. For now, that's enough. But what can we do with an array? How do we check every single value of it? Another thing comes into rescue, and that thing is called a loop. So if we want to go through the whole array, we can write ourselves a loop, a for loop, for example. So please say if I'm being too fast, because there is a lot today to go through, and I might be too fast. And if I am, stop me. Write minus minus if I'm too slow, or plus plus if I'm too fast. Sorry, write minus minus if you want me to slow down, and plus plus if you want me to speed up. Yes. So this is an array. We got an array by splitting that text by an empty space. So if we split every part, we get words out of this text. Words which are stored into an array string. And to go through that array, we will use a loop. So a for loop has a start, and that's the thing I just wrote. It starts at 0. It has an end, or in other words, how many times we want to repeat something. And I want to repeat this for as many words there are in this ingredients list. And in the last part of a for loop, I need to specify how do I change the index in every iteration. So I add 1 to the index. That's what I do with it. And this is my for loop. And in a for loop, I can now work with elements of an array. So I can take the first word in the words array, or word at some index. So let me again summarize what I just wrote, because it might be hard to understand for someone who is new to programming. Splits text by an empty space into words. Words are stored into words array. Array symbol is this. String array is an array of string. That's pretty much it. And next bit, a for loop has a beginning, index equals 0. It has an end, so we continue until we reach the end of words, and oh my god, that's annoying. And the last thing it has a change. So we increment the index by 1 in every iteration. Those are the 3 things a for loop has. And of course, repeatable code. So this is repeatable code. And we will repeat this line of code for as many words there are. So basically, if I print every word right now, which we split from a list of ingredients, you will see every word listed in a single line. So let's do that. Let me delete this line as it's not necessary, and let's try again. So you can see 1.5 cups, all-purpose flour, 3.5. Basically, every single word in a recipe was split by an empty space. And now in a new line, one word is printed in every line. That is fine, but that's not very practical. We need to do something about this. We need to work with this. So what exactly are we trying to do with this recipe again? We need to find keywords. Keywords such as cups, teaspoons, and tablespoons. So if such keywords are detected, we should then go one word backwards and see what was the amount, and then replace this and this with the equivalent amount. Let's try and do that. But as I said, let's first figure out what the algorithm is. Let's lay down the steps. So the steps are as follows. Is the word a unit of cooking? If it is, go back one word to find the amount. Then find the equivalent unit, equivalent milliliters multiplier for that amount. That's basically the algorithm. And then multiply the amount from multiplier, replace the amount, the old amount with the new amount, and replace the old unit with the new unit. And that's pretty much all the steps in this algorithm. So let's try and get this implemented. So I will no longer need this. I will need this. I will move this to here. And I will no longer need this. All right. So let's move this into a function of its own. So I'm cutting this code into another function, and I'll call it cleanup recipe. Standardized recipe maybe is a better word. Okay, sorry. I cut the code all except the ingredients part, and now I'm making a new method. And the method will be standardize recipe, and we take string recipe. I paste, And then every single comment that I have here will be a function, a new function. And before we proceed, we have one question. Can you give us the string so we don't have to type the whole thing? I'm sorry, I'll give you the string. Here you go. Nice, it's too long. It's still too long. Oh, dog. Okay. Just add a quote in the end and should be good. All right. So just typing the same thing, ingredients, that's it. Just refactoring. Post it on Discord. I'll post on Discord, my bad. Post it on Discord in Discord channel. Here you go. Let's continue. As I mentioned, every single comment is going to be a method of its own. For now, I'm just returning the defaults so that the code compiles. I don't do anything else. The first comment will go into a new method. So I write is the word a unit of cooking? So I'll literally call the method like that. Static bool is unit of cooking. So it takes a word and it returns whether or not that word is a metric of cooking. How can I determine if any string is a cooking metric? And here comes another new thing. So an if statement. If literally means what it reads or what it says. Do something if the condition is true. And in my case, the condition is cooking metric. That's what I need to determine. If it's a cooking metric. How can I determine if something is a cooking metric? I need to compare the given word with the possible metrics. So again, what are the possible metrics? Cup, tablespoon, and teaspoon. So I'll take those. And I need to do something with the word to make it belong to either, to check if it's any of those three things. So to compare things, you can do this equality comparison operator to see if things are equal. So I'll say if word is equal to cup, then all good. I'll do it super silly right now, and soon we will refactor. So an if statement also has a else part. So you can chain as many if statements as you want. If condition, else if another condition. So we have those three conditions, and I'll change them like this right now. We'll soon refactor them. Refactor 2 times, actually. So again, else if word is equal to teaspoon. This is not good code right now. I'm just teaching a principle. Definitely looks weird, but soon it will make sense. So basically, we literally did as required. We checked if a word is equal to any of those. Of course, there would be a problem with capitalization, and we'll resolve that. But for now, we are just checking the basic stuff. We'll soon approach that thing. If we compare this like this, we will kind of get the answer we want. So I will comment this out for now and just see if our method is working. So if I type, let's say, cup, I expect this to be is unit of cooking to be true. Let's run this. And it is indeed true. Let's try with those three things. So I will delete this and just paste that here and try with three different things. So we have tablespoon and we have teaspoon. Let's try those three things and they're all true. And let's try one more case, one more scenario which would cover our assumptions. So let's write a nonsense word. So we expect that this last one will be false. And it was indeed false. So bool is a type to store a logical value, true or false. So no matter what we pass, we will always get one of the two values, true or false. And actually, what we have is very silly because it's not that we are checking, like, not that we have to have separate conditions. Like, logically speaking, you won't be checking if something is this, and then you'll check if something is that, and then you'll check if something is something else. You will be checking if that word is one of those possible options, either of those possible options, and that is called an OR operation. So we want to see if the word is a cup or a tablespoon or a teaspoon. And in logical algebra, that operation is called an OR. And it's done with this operator, two pipes. So I want to say if word is cup or word is tablespoon or word is teaspoon. And now I don't need those anymore. And I'll delete those for now. So this simplifies things. Let's run the code again to see if we didn't break anything. And again, we see the same outcome. And again, this in itself returns true or false. So we don't need to check a logical condition to return another logical condition. we can immediately return this whole thing. So I'll cut the contents of if and simply return that. And now it is as short as it can get. So we're basically returning whether the word is a cup, tablespoon, or teaspoon. And that's a very common beginner mistake, to put stuff always in an if statement, regardless of it being perfectly fine with, being returned immediately. So prefer to do it like this, to return immediately. So let's run again. And we see the same results. Everything is good. As someone mentioned, there is a problem. What if I write cup with a capital C instead of non-capital C? I should still get that it's a measurement of cooking. So I need to be a little bit more smart about how I compare those things. And simple comparison as this is not enough. If I want to ignore the case, I will need to compare it with a string method. There is a special string method called equals. And when I pass equals, it expects another string or an object. But I also have an option to choose how I compare two things. And how I compare two things, I want to ignore the casing. So I choose exactly that. Let's write the same thing for all three. So word dot equals to tablespoon, ignoring the casing. Ignoring the casing. Sorry, wrong one. Ordinal ignore case. So this is what you should be using always when you want to compare ignoring the case. Alternatively, you could lowercase both and compare that way, but it's not as optimal as this one. This one is made exactly for that. So we have a proper comparison now. So when you want to compare whether the strings are equal, ignoring their casing, use dot equals with this argument. So we have a decent method to check if a unit is a measurement of cooking. That's good. So I will replace this comment with this method. And I'll say is unit of cooking. So it says if is unit of cooking, do something about it. Go back one word to find the amount. So it's safe to assume that if we are at a cooking measurement, the word before that will be a cooking amount. So cooking amount. or rather amount text, is the word before that. So it's the words before the index we currently are at. Makes sense, right? And now that we know it's a unit of cooking, we know that that element is also an element of cooking. It's some unit. The word we are at is some cooking unit. So we need to find its multiplier. So we got the amount. Find the equivalent multiplier is where we are at right now. So now it would make sense to make use more of what an array can do. So at the top, it would make sense to define these things, units and their multipliers. Like, what does each unit equate to, translate to? Let's do that. I will use double array for multipliers. So basically, you can define array with known values like this. Curly braces, and then just type the values. So my values are 240, 14.79, and 4.93. Everything in milliliters. And then another array will be of cooking units. I will not write private, I'll write static. Again, everything is static for now, don't think too much about it. So the units, I'll just name them cup, tablespoon, and teaspoon. That's all. Very simple. And I'll go back to my function, and instead of is unit of cooking, I'll change this to find unit of cooking index. So well, maybe this is fine for now. Actually, this is fine. Ignore this. We'll create a new method. So let's create a new method, static bool find, maybe multiplier, not the index. Yeah, find multiplier of a cooking unit. How many milliliters does one cooking unit equal to? So what we can do is run a for loop for every unit. So again, standard stuff, it starts at 0. We go through every single element in the array of units, and we increment the loop index by 1 in every iteration. And we're doing a lookup, so if we find the cooking unit we were looking for, units at index equals cooking unit with casing ignored, then we will, so this actually returns double. If we are at the unit of the found cooking unit, if we found that unit, that means that, for example, first in the units has the first multiplier in multipliers. So I simply return a multiplier at the same position. If the whole loop went through and no element was found, I will return -1 as a standard value of something that wasn't found. So this is fine, and this is fine. So find the equivalent multiplier for that amount is what we will do. But before that, let's see if it works. If I type a cup, I expect for 240 to be written in the console. Let's see if that is true. That is true. So let's assume the thing works. Let's call it here. And let's put the cooking unit in here. So what is the cooking unit? It's the word itself. So cooking unit is the word itself. And we put in cooking unit and we get multiplier. So now we have a multiplier with a cooking unit. All we have to do now is to convert the amount text into something that we can do arithmetics with. So we need to parse, in other words, which I will do right now. So we have amount, which we parse. We parse amount text, and we multiply that from a multiplier. And we get amount in milliliters. And the last thing I need to do is replace the old amount with the new amount. So words at index, which is the cooking unit, actually. The cooking unit is milliliters. And words at index -1, which is the amount, is the new amount, which is amount in milliliters. Which I need to convert to string. And that would be all for the conversion, and I assume it works. Let's try it. So standardized recipe. And let's delete those test subjects. And let's print it. Standardized. Let's see what happens. Nothing happens. because we return an empty string, obviously. So the last thing left for us is to get back to the parts of a recipe and stitch them together back into a whole, because we are all the time working with words, not a bunch of text. So we need to stitch that together again into something usable. And we can do that with combine parts of string into one string. And we can do that with string.join method. So string.join requires a separator. What determines, like, not what determines, but how do different things get combined? How do we combine words into a lump of text? And the answer is, well, the same way we split them. We split by an empty space, and we'll join them by an empty space as well. So I join them through an empty space. What do I join? I join the words. So I join the words and I separate every word with a space, because that's a definition of word, literally, something separated by a space. And if I run this now, you will see that it's not really working as expected. One measurement got correctly translated, only one. Would anyone be able to guess what was wrong? Where did we go wrong? And the answer is in those strict equality methods, because if we look at our input, we don't have cup, we have cups. So we need to check both singular and plural forms, or multipliers match the units array. That is fine, but we have a bigger problem. So we need to do something about that. So we could basically do this. It needs to match this, or it needs to match this. With a plural form, as you guys said. Equals this. Brackets. So it has to match either a singular form or a plural form. And the same in here. I'm duplicating the lines. So, or match, oops, or match cups, or match spoons, or teaspoons. And this one, like this. So if I run this code now, we have a problem. The contains would help, but we would have a different problem with cupboard. Like, let's say we find a word cupboard, and that will be contains with cup. So we don't want, to be so shallow about that. It's risky. Let's run again. Format exception was not in correct format. 51. 51. 51. Yeah, not specific enough. So the problem right now is I don't know. We find a multiplier and amount text. Oh yeah, teaspoons would be messed up in those scenarios. Contains wouldn't work at all. So for those of you who don't know, contains just checks if a string contains another string. In our scenario, it's not the greatest thing. Right. Let's print the currently processed word so we better understand what is going on. Cooking unit. And the amount text. Let's print those things. Cups, 1.5. Right. So I think I need to specify the format of this text for amount to work correctly. Because it assumes the default culture, which isn't really correct. Culture info dot invariant culture. Let's try this one. All right, it did work. Let's remove this right now. I'll add a note to myself and you guys. Culture invariant allows parsing numbers which has a dot as a number decimal places separator. My culture, I think it's UK or USA, and it's not that, not a dot. So that's why. Or maybe it's Lithuanian, I don't know. But anyways, if you want dot to work when you're parsing, you need to specify culture invariant when parsing. Let's run, and we see this text, which is correct, I guess. 360 milliliters for 1.5 cups. That sounds reasonable. 17.255 teaspoons baking powder, milliliters, I mean. Yeah, that sounds correct. 4.93 milliliters salt. Again, everything makes sense. So I think it's working, guys. It looks like it's working. So last thing is for us to clean up a little bit. So we have a cooking unit, amount text, multiplier, everything is good. So what are we doing here? We are replacing a cooking unit, basically standardizing cooking measurement. That's what we're doing. So I'm cutting this code and I will create a new method calling it standardize cooking unit, to which I pass index and nothing more, I think. And words array, of course. So I say static void standardize cooking unit. I pass in an index and I pass in a string array. And then I paste the code I had from before. Words at index is the cooking unit. Yeah. And the rest remains the same. So this is fine. This is the code we want to end up with. Joe asked, what is the difference between the parse and convert methods? That is a great question. So if instead of this method, I used a convert, so let's give an example in here. Let's say we have a string number 15.5. And let's say I want to convert that number into a double. I might do this. Or I might do this. And let's see the outputs of each. Well, string was not in correct format. Let's change it and make it in a correct format. So both produced the same thing, right? Everything is great. Now let's comment this one out and just leave this and write, let's say, 0.5. Okay, not in correct format. What if I do x? Okay, also not in correct format. If I pass a null, an undefined string, as you can see, a 0 is returned. If I pass the same in here, you will see that I will get an error. So that is the main difference. And another difference is that when I'm parsing with parse, I get to choose how I parse. And you can see how many ways there are through which I can parse a number. However, I don't really have anything for this one, or rather I do, but it follows a completely different structure. Like, it's not meant for parsing. It's meant for, I don't even know what this is meant for. I would say avoid using this, prefer using parse methods, and ideally TryParse, about which we can talk right now actually. So parse is also not very useful, but TryParse is very useful. So we pass in a number and we get information whether the thing that we are parsing is a number. And to get the actual result, we need to out it with an out keyword. So you see now both return 0 because my TryParse failed and it set number to 0, the default value. And this one, however, is false because null is not a number. We don't know what it is. So we cannot say that it is a number. If I run this again, you will clearly see a false for is number. So that is the main difference. I would try to stick with TryParse as much as you can. So some points of interest. What happens if you try to access an array, an element of an array which does not exist? So this could mean two things. For example, I have an array which is undefined and I'm trying to print its first element. What happens? Let's try and find out. You see, it says system no reference exception. That's the exception which happens when you're trying to work with things which don't exist. Now, let's make this slightly different. I basically created an empty array which has no elements. And I'm trying to access the first element of that array. Arrays index starts at 0. First element of an array is at index of 0. Don't forget that. So if I try to access the first element of numbers array with a size of 0, I get a different error, index out of range exception. We were outside the bounds of our array. An empty array has no elements, so accessing one makes no sense. And now, last thing, if we have an array with 5, size of 5, but we don't assign any value, we get a value printed actually. 0 works just fine. So 3 kinds of, things we should pay attention to, and I'll move this all the way to the bottom. Right, static void demo array. let's have those scenarios. So prints 0. If I say the same thing again, it says error in the no reference exception. And if I say this, with 0, it will say error index out of range exception. So be aware of those. And now let's take a little break by Kahoot, by playing a game of Kahoot. So let me get Kahoot. Nice, I don't have it at the ready. And I even messed up the URL. Do I really not have it at the ready? Nope, nope, nope. Okay, fair enough. Here is the link to Kahoot. Here is the pin. Tablespoon. Let's wait a few minutes. Those who feel a little bit tired, go take a break. It's fine. This is just a chill moment. I think we can start. So first is a warm-up question. I hope I move your camera, that's right. Thank you. I am not sure why. I'm sorry for the pin. 0 points for this one, so don't worry. Now real game begins. I did not talk about this, actually. I'm sorry. But maybe it's intuitive. I forgot to mention. So continue. Yes, continue actually as a it basically says continue to the next iteration of a loop. It says jump to the next iteration of a loop. Continue, basically continue to the next operation of loop iteration. That's what it means. this should look familiar. Yusuf said that recipe app got confusing, too many methods, and I totally agree. It certainly has too many methods in one place. Next week, we will try to split it up a bit and refactor. So if we go back, what happened here is we created an array of 10 elements and another array of 1 element with a value of 10. That first element has a value of 10. So if we add the two lengths together, 10 and 1, we get 11. Therefore, that's the correct answer. This might not be obvious, but maybe I will give you a hint. Here is a hint. Okay, well done. Oh, this is not needed. Okay. What will be printed to the console now? So a string is just like an array of characters. And a for each is a kind of loop which goes through every element in an array. And a break is a thing which stops the array completely. So what happens when it hits letter O? Hell happens. So it goes through every letter and it says H, is H equal to O? No. Is E equal to O? No. And in the end it says, is O equal to O? Yes. So stop the loop and don't print the last letter, and thus we get hell. Let me bring back the hints. What will be the result now? And the answer is true, because false or false is false. So then these two falses become false, and we group that with another false, which still is false. We group that with another false, which is still false. But false or false false or true, then becomes true. And this whole block is true. So it's like basic algebra where you consider these as summing things together. So you sum two falses and you still get a false. And you keep on summing, and eventually you're here and you sum these two and you say it's true. What does every loop have? There are different kinds of loops, but every loop has something special. Not all of them have it explicitly, but every loop has it. It is red indeed. Increment is increment is not something that your loop always has. Remember, there was a for each loop which had no increments. And then we have a while loop, which is another kind of loop, which doesn't need an increment. What will be printed to the console now? This was demonstrated in the lesson already, so you should know. That's right. So what happened here is we created an empty array, and what happened here is we tried to access the first element of an empty array. The array does not have that element. The array size is 0, but we are accessing the first element, and therefore this will throw index out of range exception. When should you choose for loop over for each loop? Remember, for each loop was one which goes through every element of an array. So if both of those are actually true statements in general, but why is for loop better? When should you choose it? Obviously you choose it when it matters, when the thing that it works with matters more, and the thing that it works with is the index. So when we need to make use of an index, we shouldn't be using for each. because otherwise it will require us to manage the index ourselves somewhere, somehow. And in those cases, a for loop is more convenient. Arthur said for each is always slower than for, I think. Sure, a little bit, but the difference is super small. When your code gets compiled, it's likely that, it's likely that it will be optimized in such a way that you will not see a difference. No, not quite. You should use for each when you literally want to go through every element in an array. Doesn't matter if you're changing something, if not. For example, think how painful it would be to not to remove, but to print every other element of an array using a for each loop. Using a for loop, you can simply say, is the number of index, does it divide from 2? If it divides from 2, don't print that number. If it doesn't divide from 2, print that number. And you print. Has nothing to do with modifying state, but involves index in determining your choice. So index, when it matters, use a for loop. That's what a for loop is for. No pun intended. Which one is not a valid way to check if a string text is null or empty? So this sign is used for comparison, for checking equality. But one of those is different from others quite a bit. I'll give you a hint. This does exist. Is null or empty is a valid string method. Is not a valid way to check if a string text is null or empty. So what does this do? What if string is null? What happens with this line of code? What happens when you try to access a property of a thing which does not exist? It will throw null reference exception. So if text is null, it will throw. In this scenario, if text is null, this part will hit trigger and will not move to the right side. So this one is wrong because the sides are mixed. Yes. So it's worth mentioning what this means in terms of shortcutting. Let's have text, which is null. So it's a string. Oops. Okay, and let's paste that one in here. Right there. So what happens is that you get a null reference exception, right? But if I change the sides, I will not get that exception. And so I'll comment this one out so you can see that this works fine. And I'll show you one more thing, how I can mess this up, and you should be extremely careful not to do this. If I delete a single pipe symbol and run, you see I still have an exception. So double pipe symbol means that if the left side has no influence on the outcome of this result, in other words, if this side is true, means I don't need to check this side to see if it's true or false. I know already that it's enough for the whole expression to be true. But with this one, it will evaluate both parts regardless. So this one is a smarter way of checking if a condition, if combining conditions results in true or false. So always compare using these double pipe symbols or double N symbols. Always, 100%. There is no reason, not a single reason why I should be using this one. I mean, you can come up with a practical reason, but people are not using this enough to be aware of the, consequences that might follow for using this. And the consequence in this case was that it wasn't intuitive to figure out that it goes to both parts regardless of this being enough to determine the condition. So be careful not using this because it might ruin your things of checking stuff. So this is error, this is okay, this is error. Let's move on. Last question, I think. What will be printed to the console? So you have an array of numbers, and you go through those numbers one by one. And if a number divides from 2, or not, you do something with that number. Or not. Again, I missed quite many things in this lesson, which are in Kahoot, which I didn't mention. But I hope that's fine. As I said, not everything is always practical or coverable, and there is theory in any way which you can go through. The point of the lesson is to get you into the trenches of programming, which I think I am okay at doing so far. So what happens here is there are 5 numbers in the numbers array, 4, 3, 2, 1, and 0. And this for loop goes through every number in the array. If that number divides from 2, so this symbol, this percent sign says, get me a remainder of a number. So if I divide 4 from 2, I get 0. So does 4 divide from 2? Yes. Print that number. Does 3 divide from 2? No. Don't do anything. 2 divide from 2? 0. Print that number. And then 1 divide from 2? No. Don't do anything. 0 divide from 2? 0. Print that number. So the answer is 4, 2, and 0. It's not 4, 2. And it goes all the way till the end. because the last element is not at the length index, but at one index lower. And the winners of today's quiz: Brian third, Stink second, and Can first. Congratulations. Joe fourth, and YHWT fifth. And the question you got wrong the most. Which one is not a valid way? Check if string is null or empty. Only 5% got it right. Oh my. What does every loop have? Also, only 27% got it right. Okay. From all the things that might be useful, I don't know if I should be saying all the things that might be useful. But it's worth going through slowly. So there are two kinds of loops that I didn't mention in these examples. There is a while true loop or a while condition loop. So first, okay, while condition maybe. It's a loop which runs for as long as a condition is true. And in this case, a condition is always true, and therefore this loop will never stop. However, I can always stop a loop by running a break statement. So while loop runs for as long as the condition is true. In this case, a condition is always true. However, we can stop the loop by running a break statement. So that's a while loop. We can have any condition here, but a condition based on index wouldn't make sense because we have a for loop. So I will not convert the same loop to a for loop equivalent because it's just not practical. And lastly, an actual proper conversion would be converting this into a for each loop. So I will not need this. Well, I will need everything, but I'll change it completely. So I'll say var. Oh, right. I need everything here because I am working with an index. See, I'm passing index in this method. So it's important. I cannot let it go. So I will not change anything here. However, here it's a little BS. And I will remove this method. This method is actually a duplicate of this method because here I do a search and here I do a search as well. So I don't need this method. Though I do need the comments. Okay. And I'm deleting this. So finding multiplier is a matter of finding the right unit and then getting a multiplier of that unit. And if it's not found, it's -1. So in here, I don't know if it's a unit of cooking, and I don't care. I don't care about, I do care about this, I don't care about this. So now it's slightly more readable. We can see what we're doing. We split the recipe into words. We standardize cooking unit at every index, and we join it back to a fixed recipe. So standardized cooking unit takes an index and words. And what happens next? We find a multiplier. So if multiplier is -1, what should we do? Nothing. We should stop this operation immediately because it didn't find the cooking unit. We cannot do any replacements, so we should better stop. If it did succeed, we can continue. I could have written an if-else statement here, but I chose not to because this doesn't create an unnecessary scope. This allows me to have a single scope across the whole function. So it's valuable, it's useful, it's more readable. So I don't need this anymore because I already have a conversion. So I can easily refactor things. Like all of those things are not needed anymore because I have it practical. So our recipe app now is really just a few lines of code again. Let's move this out. And that's really it. So static void demo unrelated. I don't even know if I should keep it. Yes, Michael asked a great question. How to define a term refactor. So for example, right here, I have a method, demo loop, which is never used. What do I do with it? I can refactor it. The best kind of refactoring is deleting code. I don't need it, I delete it. Another kind of refactoring is if you see a function that does too many things, you extract a part of it into a function of its own. So this standardizes recipe. Right now, my functions are pretty, I would say, pretty well split. I cannot split anymore without repeating myself that much. Maybe this one, maybe, but I don't think it's necessary. I like personally, I find this decently readable. So what I have here is already refactored, which means the code is clear enough to understand. All those comments are just for, tips for you to learn, to better understand what is written. I wouldn't write those comments in production code. I would delete them. And deleting these comments would be my way of refactoring the code, clarifying what is written, removing redundancies. I would say those are the two things which I would identify refactoring as. Removing redundancies and clarifying what was written. How do you clarify stuff? I would split stuff into methods, occasionally write to console. Okay. Do I have anything else for today? Well, as mentioned, the things that I haven't mentioned is in the wiki. This time the wiki is actually pretty long. I did not want to make it so long, but it just happened. It's like, you can see how long this is. But this has everything you need to know, almost, about if, arrays, and strings. And loops as well. And a practical problem as we solve it by going through this article, finding prime numbers and formatting them. So I recommend reading this wiki. I put a lot of effort into writing it, and it definitely covers the things that I didn't cover in the lesson if I didn't. So that will be all for this lesson, and now I will go on Discord if you have any questions. Yusuf asked for too many methods and too many deletes. Can you explain from the top? Yes, let's summarize what we have written. So here we have written a text, our recipe basically, which we are trying to process, to parse. And the whole point of this application is, as you can see, to standardize the recipe, changing cooking units into SI system units. So cups will be converted to milliliters, teaspoons and tablespoons will also be converted into milliliters. So the first thing we do is we split the recipe word by word by splitting it through an empty space separator. We then try to standardize a cooking unit by first finding its multiplier. What does finding a multiplier mean? It means that the cooking unit, or the thing that we assume is a cooking unit, the thing that we assume is a cooking unit will be one of those units. We will find it in these units array. And we don't care if it's camel case or not. We assume that, like, we don't care if it's what its casing was. We just say if the text matches, it's good, it's found. And we also check for plural versions just in case. For example, there can be a cup or cups, which both are valid. And then we take, based on, since the position of a unit matches the position of a multiplier for that unit, if we found the unit, we can say which multiplier was of that unit. So we do that, we found it, and if we don't, we return -1. Lastly, we do the actual parsing and conversion. We get that amount text unit, which is one word behind. For example, here, if we have cups, one word behind is amount of those cups. If we have teaspoons, one word behind is amount of those teaspoons. So we parse the amount, which is one word behind, and we multiply it from the multiplier we found. And then we replace the things with the unit which we converted to and the amount which we converted to. So that is all. Yes, multipliers and units must be in the same order. In this application, until we learn a little about object-oriented programming, that's the best we can do. Obviously, this would not be the right approach if you knew more, but with the knowledge we have, this is sufficient. That has to suffice. So that's the application. It's I hope, simple. I will push the code right now, and I will go to Discord. so you can ask me questions. Hello. Before I answer your questions, if you have any, I'll answer those from the chat. Vitska asked, I'm wondering as well, what would happen if you remove from an array while going through a loop? You cannot modify an array that you can. Array is immutable. You cannot change its size. So you cannot do that. Nothing would happen. Dogfish, I cannot hear you.
Oh, I'm not talking.
Yeah. Okay. Now I can. Okay. Hello.
Hello?
Do you have any questions?
No, sorry, I was just idling here.
It's fine. Okay. All right. I'll wait a few more minutes, and if there are no more questions, the lesson will be over.
So, actually, I do have a question then. I guess, is the homework on the Git site or wiki?
Yes, if you are looking at my screen, and if not, I'll just paste something in the voice channel. So if you scroll all the way down, there's a homework section. And this homework is way bigger than the previous one. But it teaches you very good things, I think.
Okay, cool.
About the code, for now, just post in BC student, BC homework channel.
Got it.
Arthur asked to explain static string standardized cooking unit again. Yes. So standardized cooking unit method basically takes actually, this is a scary part. I shouldn't have done this. Let me do it like this. Yeah, that's better. So we go through the array of words, the words which are in recipe, and we look if a word is a multiplier. Sorry, if a word is a multiplier of a cooking unit, or in other words, if a word is a cooking unit, we can return that cooking unit's multiplier. If a word is not a cooking unit, the multiplier will be -1. And if the multiplier is -1, it's not a cooking unit, there's nothing else for us to do. So we just terminate the function. However, if it is a cooking unit, we grab the amount which always goes before the cooking unit, thus the -1 index. And thus, when we have the amount text and the cooking unit, we can then parse the actual amount and multiply it from the multiplier of that cooking unit, so that in the end we have all that we need. The unit to replace the cooking unit with, and the amount which is calculated after the conversion. So that's that. Right. I put a question in BC discussion. I'll have a look if I haven't yet. Actually, confused. Okay, where the hell is BC discussion? I don't see the question. I don't see the question. I'm sorry. I'll move on to the next one. Gregory asked, the arrays we have to do the operations on are of integer type. Arrays can be anything. Arrays can be of any type. The arrays we worked with are strings, as you can see here. And other arrays we have are double. But the key point here is that an array index, yes, you're right, it has to be an integer. So I guess that's what you were asking. Sam asked the question, what would you suggest us to be able to follow you efficiently during the live stream? I don't know. I don't know yet. It's an issue. It's definitely an issue. And that's why I'm gathering feedback after every lesson, so in hopes that maybe you can help me with that as well. I don't know. What I expect you is to let me know if I'm being too fast, so that if I am being too fast, let me know, and then I'll slow down and I'll repeat the same thing again. I am pretty sure that I am not being like very clear with what I'm saying, and there are many questions after something I say, especially in this lesson. I don't feel I did a great job. Therefore, please let me know so that I can, not only rely fully on myself, but on you guys as well to control. Yes. 2 screens, in my opinion, is essential. Again, if you have any questions, let me know. But the answers I am pretty sure you'll find in the wiki, so no worries. I am not a talented teacher, but thank you. Acceptable Somerset, I thought for each cannot change what it loops over. Is it not true anymore? See this example. So when someone asked a question, they were referring to an array. And you cannot change, the array doesn't change, so there is not like the question of modifying the thing you're iterating is out of scope of this lesson, because you cannot do that with an array. But with a list, it wouldn't work. You cannot, as you said, change what you're looping. That's right. But I mean, you can change what you are looping, but you cannot mess with the order of things that you are looping. You can mix elements together as you loop, but you cannot really do that with a list. Well, maybe you can actually, I don't know. With an array, you would swap indexes and that's fine. You cannot remove anything, so you cannot add anything. Arrays are immutable, and that's why array is such a classical structure, because it simply works, right? But yeah, adding and removing elements is forbidden when you're iterating a collection, but swapping them is absolutely fine. Arthur Pendragon asked, static void standardized cooking unit int I string words is string words. Copy of the array or the array itself. It is a copy of the reference to that array. And that's actually a great question. So Arthur asked, what happens to the words array? Do we work with a clone of that array? Is it a copy or is it the same array? And the answer is actually it is neither of that. When we pass an array, we pass a reference. And actually, we don't pass the same reference, we pass a copy of the reference. So when we work, it's basically like giving a, what's it called? Like your visit card for multiple people. So when you are calling a method, you're basically giving your address to multiple people. Imagine you are a variable which is passed by a reference. And a method is what has to call you, it has to consume you, so it give it your address. You don't give yourself to the method, all you have to do is give address to how to locate you. So here we just give an address, how to locate words, a copy of my address. And I'm working with a copy of an address. Copying the whole thing would be way too expensive. Therefore, that's not how it works. And last thing, how to prove that, if I say words and create it from scratch like this, you will see that nothing happens. This array will not be modified, and after I am done, well, I have a bunch of errors, but basically this means that I don't affect this array at all. I'm working with a copy to a reference, so it doesn't matter. So again, to summarize, you're working with a copy of a reference. That's how it is. Any more questions? Hello, sound. Michael Chandler asked, so when you mail a letter, you don't rip the address of the building and glue it to the employee and to the envelope. Is that a good analogy? Of the building and glue it to the envelope. Yes, that is a good analogy. I think you got it. So instead of, yeah, you just copy a reference. You just copy an address. Yeah. I cannot say a better analogy. That's as close as it gets. All right. Any more questions? If not, I'll see you in the next lesson. Again, please fill the survey. It's this time about the exact time when you want the lesson to be, because there was a shift of, the clock, and we had some issues with the exact timings, so it's not really nice. And I would like to know what people think now. I prefer 1 hour earlier. Someone else said that too. And summarizing everything, we'll adjust the time for your convenience. So see you in the next lesson, where we will talk about debugging and files processing and error handling. So see you and have a good day. Bye.